Hello worldwide sales team. Today I'm going to introduce the T-Scan Track to you more in detail. I would like to start with the greatest things about the T-Scan Track. It is a mobile measuring room, as you can capture 3D surface data of a part very fast with a laser scanner and measure optically hard to reach areas with the tactile probe. As it comes with an optical tracker, there's no part preparation required, like using reference points. Put a part into its tracking volume and you are ready to measure. The biggest tracking volume is 20 cubic meters, with which you can measure parts up to 4 meter length in just one single tracker position. You can also measure parts which you cannot keep in a stable position. Hence, high precision measurements don't have to stay any longer away from bustling shop floor conditions. So how does the system actually work? Let's begin with a closer look through the handheld laser scanner. As you can see, a laser line gets projected on a part, which gets deformed by the part-specific geometries. This deformation gets captured by a camera, and based on the idea of laser triangulation, we receive the 3D information of the single line scan. Since we want to capture an entire surface, we need to move the scanner over the part. But how can we locate each single line scan in 3D space? Now the optical tracker finds its stage. Perhaps you already have noticed the antennas which are mounted around the scanner. When we take a closer look, we will see those infrared markers which permanently transmit infrared light. All infrared markers together define a rigid body. This rigid body gets tracked by the optical tracker. You can dynamically scan the complete 3D surface by moving the laser scanner over it. This dynamic way of scanning is possible thanks to the optical tracker. It permanently captures the position of the laser scanner in 3D space. It is like you are painting the part. This combination is the most intuitive and natural way to receive the digital twin. There's visual and acoustic support for the user to stay inside the scanning and tracking volume. You find these LEDs on the backside of the scanner. They help you to stay within the appropriate working area. You have a green pilot beam in addition, which gives you actually the same information. The scan resolution ranges from 100 microns at the far ends up to 50 microns at the close end. The software guides you to stay inside the volume of the optical tracker. I would like to speak now about the accessories you can get for the T-Scan Track. As already mentioned, the system includes a tactile probe to measure single points on a part, which is also tracked optically in 3D. It comes with a selection of different stylus lengths and tip diameters. The tactile probe helps you out when you want to measure features which you cannot measure optically. For example, the depth of a narrow hole. Furthermore, the tactile probe is the fastest measuring possibility when you just want to inspect single points on a part, like for example center points of holes. A guided software workflow in the GomInspect suite makes it very easy for the user to work with it. Before we start with the inspections in the GomInspect suite, let's have a closer look to the scan data quality of the T-Scan Track. Are the tubes welded in the right way? This question is easily answered via a surface comparison between the nominal frame and the digital twin of the real one. This side has a maximum deviation of just a few tenths of a millimeter. However, the other side has very big deviations of more than 10 millimeters. Hence, this side is deformed and need to be corrected. Dimensional inspections can also be carried out very fast and intuitively. All kinds of inspections can be considered directly in the 3D space, like the frame length or the steering head angle. This little hemisphere is called spherical mounted target, also just called SMT. The center of an SMT is calibrated and can be detected by the tracking system in real time, as there are several infrared markers installed. In whatever direction they point to, the calibrated center stays in the same position. You can use up to 6 in the same time to align different tracker positions without losing accuracy. We will see later how it works. You can easily calibrate the optical tracker in the field. This dynamic process is called in-field calibration, also just called IFC, and it just takes 3 minutes. I already mentioned that you even can measure parts which you can't keep in a stable position. This collection of infrared markers called dynamic referencing makes it possible. You just need to put them on or around the part. They are magnetical. We have 2 versions of the T-scan track in our portfolio, the T10 and T20. The 2 main differences are the respective tracking volumes and accuracies. The number 10 and 20 are standing for the tracking volumes. Parts up to 2.5 meter length fit inside the T10 volume and parts up to 4 meter length inside the volume of the T20. The maximum length measurement error for the T10 is 30 microns plus 30 microns per meter, and for the T20, 40 microns plus 40 microns per meter. An important aspect to mention is that you can upgrade from a T10 to a T20 if you realize one day that you need a bigger tracking volume. We see the T-scan track as a system of choice if the user doesn't want to have the effort with part preparation, like adding reference points. If a measuring system is required which can scan and probe. If specific areas of parts should get quickly checked, like it is required for the incoming goods inspection. Or if you want to measure big parts most of the times or just need local areas of them in one single coordinate system. The new GOM Inspect suite makes it finally possible to 3D scan with our manual sensors and inspect in just one single software environment.